this equipment is for the penetration test. And this is both with asphalt, and this is there in the middle, and this is water. And in this filter, there is the water. The water is to control the temperature, because the standard temperature for this test is this temperature 25. Yeah, to keep to control the temperature, test temperature area. And then when the test begins, the needle will penetrate into the asphalt. So if the penetration is big, it means what? It means what? It means that viscosity. The viscosity of this asphalt. If the penetration is big,
the viscosity is low.
if the viscosity is low. Yeah. If the viscosity is high, the penetration will be small.
Yes.
It will be small. Yeah. This is for the viscosity. Viscosity of the asphalt. This is the first properties. The second property is about the plasticity. Plasticity. The plasticity means the capacity to deform under external loads. You want to deform. Without fracture, without corruption, not break. It is not break. And then keep the shape of deformation when the external loads are removed. So, for this viscosity, for the viscosity of the asphalt, it relates to high temperature. Yeah, high temperature, because the deformation at high temperature. And for the plasticity, it means the deform but not break.
How is the viscosity varies with temperature?
How
Viscosity, how it varies with temperature?
how viscosity? What temperature?
Yeah. If you have temperature and viscosity, when temperature increases,
Yeah. When the temperature increases, the viscosity decreases. Absolutely.
and the penetration, if the viscosity decreases, the penetration is
Okay, I understand. Okay, for the viscosity of the asphalt. Okay, when the temperature increases, the viscosity will decrease. Yeah, but the penetration will increase or decrease. Will increase. Yeah. If the temperature increases, the viscosity will decrease, and the penetration will increase. Okay? Yeah. For the plasticity, okay? For the plasticity, it means the capacity to deform without break, without fracture. So how can we evaluate it? We can use this kind of molds. And we can pour the asphalt into this mold, and then craft it here, and then start the machine. It will just like this. 10 solid. 10 solid. Yeah, 10 solid. And when the fracture occurs, the testing stop. And the distance is the plasticity. This is the ductility, okay? Ductility test. This is ductility test. So if the ductility of the asphalt is very big, if the ductility of the asphalt is big, it means what? It means the plasticity of this asphalt is good or poor. If the ductility is big, it means the plasticity of this asphalt is good or poor.
Poor.
It's good or poor. The ductility is big. The distance is very long, very big.
Yes.
It means that plasticity of the asphalt is good or poor?
Good.
It's good. It's good. If it is poor, it will very small, it will
Yes.
fracture or break. So, if the temperature increase, usually, okay, because we have just mentioned the viscosity is related to the temperature and high temperature, but the plasticity relates to performance of low temperature. Because at low temperature, the asphalt will shrinkage. At low temperature, the asphalt will shrinkage and it will become brittle material. So if the ductility of the asphalt is big, it means it can resist the stress at low temperature. So if the temperature increase, usually the plasticity will increase, and the ductility also will increase. So this is for the second property of the asphalt. This is the plasticity. Plasticity. The third property is about the temperature susceptibility. So what is the temperature susceptibility? The temperature susceptibility means when we increase the temperature or decrease the temperature, this index will change. Yeah, this index will change. So what is the temperature susceptibility? Okay, for this kind of asphalt, okay, maybe at 50 centigrade, the penetration is about 40, but at 25%, will be 60. Will be 60. The second asphalt, okay, at 15. First one is they are the same at 15, but at 25, which one is good? It means when we increase the temperature, the penetration increase. Yeah? And when they increase the steam, 10 centigrade. But the change is different. The change for it is smaller than this one. So these are the temperature susceptibility. Which one is big? This one is big. But the big temperature susceptibility relate to so the change is bigger than this one, but it means the temperature susceptibility of this one is bad, is poor, because the change is I don't know how to explain. If for this one, the difference is just 20, but for this one it's 30. So the change is much bigger. The change is much bigger means the temperature susceptibility is big. The temperature susceptibility is big. It means when we increase 1 centigrade, the change is big. The change is big. But the big temperature susceptibility always means bad. Always means bad. Okay? So this is for the temperature susceptibility. How can we evaluate? It? We can use this kind of softened point. The softened point means the temperature is a kind of temperature. Otherwise, the aspirate changes its status. The status from the solid to liquid. Changes the status from the solid to liquid. And proceed as 10% of the distance between the solidifying point and liquefying point. Okay? And this method we can also use. We can also call it the ring and ball method. So what is the ring and ball method? Just like that. Okay. Here is a ring. Okay. Here is a ring, and we can pour the asphalt into it. This is a ring. We can pour the asphalt into it, and this is a steel ball. This is a ball, steel ball. And the weight of the steel ball is 3.5 grams. And then there are two specimens at here. And this is a cup. And there is a lot of water into it. The water is for counter the temperature. And when we heat it, the temperature of the water is also increased. And then the asphalt will soften. And then the steel ball will drop down. With the asphalt. And when it contact with the base, the temperature is the soft point. The temperature is the soft point. So this is for the temperature. For the temperature susceptibility, we can use a soft point. Soft point to evaluate soft point. For the properties of the asphalt, maybe there are multiple properties, but these three properties are the most important. Okay.
Yes.
The first one is the viscosity. Viscosity, plasticity, and temperature susceptibility. Temperature susceptibility. So if I ask you, what are the most three important properties of asphalt? You need to. They are the viscosity, the plasticity, and the temperature susceptibility. But if I ask you, what are the most important indexes?
Relative to.
Yeah, indexes. What are the most important indexes for asphalt? You shall tell me the penetration, ductility, and soft point.
Sorry, say that again.
Say it again.
Yes.
These are the three properties. Yeah, viscosity, plasticity, and temperature susceptibility.
Yes.
These are the three properties. And these are the three indexes for evaluation of these three properties. So if I ask you what are the most important indexes of asphalt, these three is the answer: the penetration, ductility, and soft point. When we evaluate the performance of the asphalt, we usually take these three index for the evaluation of the quality of the asphalt.
So last one is what? Viscosity, plasticity, and
Viscosity, plasticity, temperature susceptibility. These are most important properties, but these are the index. Okay, these are the index. You can also use the penetration index. For the penetration index, you still remember what can we do with it? To classify the colloidal structure, the gel type, the soil type, the soil gel type, with this method. Okay, with this method. So, and just these three indexes. These three indexes are for the load pattern asphalt for the evaluation. For the evaluation of the load pattern asphalt. This is the penetration, ductility, and the softening point. Softening point. And another property about for the asphalt is the durability. For the durability, maybe there are different kinds of durability. First is the oxidation. The oxidation always related to the aging of the asphalt, because the asphalt is a kind of organic material. It's a kind of organic material. So the aging is also a critical performance for the asphalt. So how can we get the aging of the